Friends, in continuation of dual nature of radiation, right? Lecture 2, let's know few other things. Dual nature of radiation, right? Already in wave optics, you have learned about wave theory of electromagnetic radiation, right? That is, one is interference, one is diffraction, and another one is polarization, right? And photoelectric effect also supports the particle nature of light. Hence, we say the chapter name dual nature, right? Okay, और एक चीज जो आइंस्टाइन फोटो इलेक्ट्रिक इक्वेशन में ठीक है you know in chemistry about the photons. What are the photons, students? What do you know about photons in chemistry? These are packet of energy, right? These are energy particles, correct है ना? Photons क्या है? These are the energy particles, ठीक है? जो कि कहाँ से आता है? Source of radiation के कारण आता है, right? So photons emitted from a source travel through the space with the same speed that is equal to light speed of light, right? ये जो एनर्जी पार्टिकल मूव करते हैं वो कितने स्पीड में मूव करते हैं? दैट इज सी स्पीड में, दैट इज 3 into 10 to the 8 मीटर पर सेकेंड. अंडरस्टूड ना? करेक्ट. एंड ऑलरेडी यू नो E is equal to h nu and L. Yesterday we learned about frequencies, velocity by time period, right? So that is equal to h is equal to nu is c by lambda, correct? Beginning lambda is wavelength, nu is frequency, c is speed of light, correct? Beginning students.
Yes, sir.
What is the formula for momentum? Momentum of photon. Photon P is equal to mass into velocity, correct? है कि नहीं?
Yes, sir.
Momentum is equal to mass into velocity, correct? We want to term it in terms of, let's do one thing, energy, kinetic energy, right? Energy by speed, मतलब velocity. See, energy by velocity. If I'll go for, right? Energy is how much? Half mv square है ना? Normally, correct? है कि नहीं? Energy is equal to half mv square, correct? हाफ एम बी स्क्वायर पे अगर आप एक v डिवाइड कर देते तो इट विल बी एम बी और नॉट, स्टूडेंट्स? है ना? यू गेटिंग?
Yes, sir.
Yes.
So you can say momentum of a photon is nothing but that is equal to momentum of a photon is equal to E by C, correct? That is approximately E is equal to h nu by C, है ना? And when the particle is at rest mass of photon is 0, correct? And moving mass is equal to how much? E is equal to mc square. From there m is equal to E by C square, है ना? E is equal to how much? h nu by C square, correct? है कि नहीं? This is moving mass of photon, है कि नहीं? All photon of light of a particular frequency or wavelength have the same energy, है कि नहीं? So you know that is equal to E is equal to, हम ये लिख सकते हैं h nu, that can also be written as hc by lambda, है कि नहीं? And you know momentum P is equal to h nu by c, correct? That is equal to also h by lambda, whatever may be the intensity. And photon energy is independent of intensity of radiation, right? And these photons are not deflected by any electric or magnetic fields. And in a photon particle collision, right, the total energy of the total momentum is always conserved here, है कि नहीं? अगर हम यहाँ पर बोलेंगे कि नंबर ऑफ फोटॉन्स एमिटेड पर सेकंड ऑफ ए फ्रीक्वेंसी, ऐसे आपको पूछा गया नंबर ऑफ फोटॉन्स एमिटेड per second of frequency nu from a lamp of power P, right? From a lamp of power P, there is N is equal to how much? Number of photons P by h nu, that is P lambda by hc, correct? You can do it also, okay? And another one important relation here in this chapter, de Broglie waves of matter and division and Kermer experiment, okay? Let's go to that once, okay? De Broglie waves of matter क्या कहता है? Let's see. Next is de Broglie waves. That is matter waves, right? De Broglie waves, or that is known as matter waves. What it says, ये कहता है कि radiation has dual nature, एक wave और एक particle. And the nature of the experiment determines whether a wave particle description is some experimental result, that is reasoning, okay? Radiation and matter should be symmetrical in nature, ऐसा कहता है, right? Louis Victor and de Broglie attributed a wave-like character to the matter particles, okay नहीं? And the wave associated with the moving material particles are known as matter waves or de Broglie waves. Light is a particle, light is a wave, right? तो जो मतलब जब लाइट मूव करता है मटेरियल पार्टिकल्स, द मूविंग मटेरियल पार्टिकल्स, द वेव्स associated with the moving mmaterial particles are known as matter waves, right? And de Broglie wavelength क्या है? What is de Broglie wavelength? de Broglie wavelength, right? ये लिख सकते हैं, de Broglie wavelength क्या है? Now wavelength associated with a moving particle related to its momentum, right? So we can write wavelength associated with a moving particle, wavelength associated with a moving particle, right, is related to its momentum, करेक्ट? इसका ये मतलब है कि लैम्बडा इज इक्वल टू क्या पता था हमें? h by p, right? And that is h by mv, ठीक है नहीं? And m is mass of the particle, b is the velocity of the particle, and p is momentum of the particle. और यहाँ पर चार्ज के बारे में कुछ नहीं है. de Broglie wavelength is independent of the charge and nature of the particle medium. And you know kinetic energy is equal to how much? Half mv square, right? है ना? अगर एक m मल्टीप्लाई करेंगे तो p स्क्वायर बाय 2m लिख सकते हैं कि नहीं? तो p इज इक्वल टू 2m इंटू काइनेटिक एनर्जी का रूट ओवर लिख सकते हैं ना? कैन वी राइट? है ना? So from here we can also write h is equal to, that is h is equal to, that is 2m into kinetic energy, there is momentum. Only you can write k, 2m into k का रूट ओवर, करेक्ट है ना? Understood? And you know h is equal to 2m की जगह में 2m kinetic energy इलेक्ट्रॉन वोल्ट क्यूब भी लिख सकते हैं कि नहीं? This can be another formula ना students?
Yes,
Getting
sir.
or not? ठीक है?
Yes, sir.
और अगर इलेक्ट्रॉन की वैल्यू डाल देंगे, मास ऑफ द इलेक्ट्रॉन, चार्ज ऑफ इलेक्ट्रॉन अगर डाल देंगे यहाँ पर, और प्लैंक्स कांस्टेंट की वैल्यू डाल देंगे, तो ऑलवेज कीप इन माइंड दिस वैल्यू फॉर एन इलेक्ट्रॉन. This lambda is nothing but 150 by v to the power half Armstrong, right? This is the de Broglie wavelength of an electron, correct? है ना? और कभी कभी de Broglie का ये भी इक्वेशन है, gas molecule, right? There is a gas molecule of mass m at temperature T at temperature T Kelvin, its de Broglie wavelength is given by, right? Its de Broglie wavelength is given by its de Broglie wavelength is given by lambda is equal to h by 3m kt, correct? And next is Davison and Germer experiment, right? What it says, it is only meant for to study the wave nature of electrons, है कि नहीं? Suggested by de Broglie, है कि नहीं? Wave nature of electrons को study करने के लिए, wave nature of electrons, है ना? Correct? Or according to this according to this, that is 1.227 divided by root over of V nanometer, right? This is the formula for wavelength, है ना? Correct? और ये एक्सपेरिमेंट भी आता है कभी कभी क्वेश्चन में वेवलेंथ निकालने के लिए, राइट? एंड द वैल्यू हमने जो ये बताया ये भी डिराइव करने के लिए आता है समटाइम्स। मतलब उसने पूछा है कि डी ब्रॉग्ली वेवलेंथ ऑफ एन इलेक्ट्रॉन, उसने पूछा व्हाट इज द डी ब्रॉग्ली वेवलेंथ ऑफ एन इलेक्ट्रॉन। गेटिंग माय पॉइंट और नॉट स्टूडेंट्स? डी ब्रॉग्ली इसका क्या फॉर्मूला है? डी ब्रॉग्ली वेवलेंथ ऑफ एन इलेक्ट्रॉन, लैम्ब्डा का क्या फॉर्मूला है? h by p, already you know that is h is by root 2 mk, right? That is equal to h by 2 into m into ev, है ना? अभी जो वैल्यू हमने निकाले, यू गेटिंग? दिस इज de Broglie wavelength, de Broglie wavelength of electron, है ना? So that is h का वैल्यू जो है कितना है? 6.63 into 10 to the power minus 34, right? जूल सेकेंड। मास ऑफ इलेक्ट्रॉन क्या है? 9.1 into 10 to the power minus 31 kg। चार्ज ऑफ इलेक्ट्रॉन क्या है? 1.6 into 10 to the minus 19 कूलम, है ना? तो अगर सारा वैल्यू डाल देंगे लैम्ब्डा में, that is 6.63 into 10 to the power minus 34 root over of 2 into 9.1 into 10 to the power minus 31 into 1.6 into 10 to the minus 19 volt, right? पूरा सॉल्व करने के बाद स्टूडेंट्स approximately you are getting, remember this value, 12 by 3 root over of V Armstrong, right? Understood or not, Ray? Getting?
Yes, sir.
ये जो 150 है ना, 150 का रूट ओवर ये भी लिख सकते हैं, दिस इज ऑल्सो ट्रू, दिस इज ऑल्सो ट्रू। एमसीक्यू के लिए आप जैसे दिया हुआ है उस तरह देखना, राइट? है कि नहीं? गेटिंग ना?
यस।
और थोड़ा बुक्स में देख लेना कि वो जो डाइविशन और गैमर का एक्सपेरिमेंट का डायग्राम है कि नहीं, कैसे हुआ था, करेक्ट? और सारे न्यूमेरिकल एक बार देख लेना, इसमें सारे चीज बेसिकली हमने निकाल दिए, ठीक है? और यहाँ पर रिजर्विंग पावर ऑफ एन इलेक्ट्रॉन माइक्रोस्कोप, राइट, इज मच बेटर देन ऑप्टिकल माइक्रोस्कोप। तो रिजर्विंग पावर कभी कभी पूछ लेता, रिजर्विंग पावर ऑफ माइक्रोस्कोप, राइट, that is 2 mu sin theta divided by lambda, that is reserving power, right? है ना? करेक्ट? सो इतना ही है, अब थोड़ा प्रीवियस ईयर के पेपर देखो, ठीक है। नेक्स्ट अगर कुछ डाउट है तो जस्ट आस्क मी, राइट।